Hello class, welcome to Geometry Lesson 1-1, Measuring Segments and Angles. By the end of this lesson, you should be able to use properties of segments and angles to find their measures. We're going to start with some vocab for you. So, undefined terms are terms whose meanings are accepted without a formal definition. So, an example of that would be a point. So, a description for a point is, we typically draw it as a dot and then we give it a letter name. So that would be point A. That is a point. You guys have been working with them for a long time. The diagram and notation columns, I really want you to pay attention to those because that is what you're going to be using throughout the whole year, okay? So a point, you draw a dot, you label it with a letter. Notation, you do whatever letter was named. They are always capital letters, okay? I don't want to see you naming points with lowercase letters. Always has to be capital. A line has arrows on both ends. It keeps going in both directions forever and ever, but we can't draw forever and ever, which is why we do the two arrows. And a line needs at least 2 points in order to be a line. So in this case, we have point A and point B. So we can title this line, we can name it line AB, and you can either write out the word line and put AB, or you can do the symbol of the line above it. Another way to name a line is you take a lowercase letter, it's usually written in cursive, but if you do a lowercase letter, you can name, that did not erase, you can name the line by the lowercase letter. So in this case, line L. And then a plane is going to be, it's going to look like a 2D figure for you guys, okay? But it goes on forever and ever, just like a line. It goes on forever and ever in all directions. So some ways that you can start to think about what a plane is, you can think about, like, if you think about the floor in the classroom, imagine that the floor keeps going on and on forever and ever at the same height and everything. That's kind of a plane. Same with the ceiling or a wall. And the way you can name a plane is there will either be a letter in the corner of the plane. So in this case, that's M. So it can be called plane M. Or you need 3 points on the plane, but they can't all be on the same line. So see how if I were to try to draw, I couldn't draw a straight line through all of them. You see, it would curve or bend. So you need at least 3 points that are not on the same line. And that term is actually called non-collinear. Not on the same line. So then another good word to know is collinear, on the same line. Okay, so the second name for the plane would be plane XYZ. Now some defined terms, there we go. So some things that you're used to, a line segment has 2 endpoints, and the notation, it looks really similar to a line, but you don't have the arrows on the ends. Okay, so it's missing those arrows, and that's because a line segment ends. It doesn't keep going. And yes, I'm going to be picky about that. Okay, so this is a segment, not a line. The second one, we have a ray. That's where you have an endpoint and 1 arrow. It can be facing whatever direction you want. But the way that you name it is you start with whatever point doesn't have the arrow, the point with the endpoint, and you then write the point near the arrow. So in this case, MN. Opposite rays are when you have 2 rays that point in the opposite directions. So in this case, it ends up looking like a line, but another name for it is an opposite rays. So we could have ray TS and ray TU. And then an angle, you've worked with angles before. Quick review on naming angles. You can name them by the number inside the angle. You can name it by the vertex, or using the 3 letters. So in this case, angle PQR. Another way that you could write it is angle RQP. So you could go this way, start at the R and go, or you can start at the P and go through the angles, okay? All 4 of those are acceptable ways to name the angle. Now, let's jump into finding segment lengths. How can you find the length of segment CD? The way that you can find the length of segment CD, you have a couple options. You can either count and say, oh, it's 3 units away. We're going to label our answers in geometry, okay? So 3 units, not just 3 units. Or if they were super far apart and you didn't want to count each one, what you can do is you can either say 4 minus 1, okay, that's 3 units. Or you can do 1 minus 4, well, that's negative 3 units. But since we can't have negative distance, we make it positive. Okay, and the way that we would write that is using absolute value, if you remember that. Okay, so no matter what, distance has to be positive. Go ahead and solve this one on your own. Hopefully you ended up with 7 units. If not, please be sure to reach out for some help. Let's look at example 2 using the segment addition postulate. So segment addition postulate is when you take multiple smaller segments and combine them to make the larger segment. So in this case, I could say CD plus DE equals CE. The whole thing, right? If I add the bluish and purple segments together, I would get the whole segment. So if I want to solve and figure out what this question mark is, what DE is, well, I know the whole thing equals 30. So I have to find out 14 plus what number gives me 30. That would be 16. So I would say, actually not going to box that. I'm going to say DE equals 16 units. All right, the second one, same idea, just slightly different. So AC, whole thing, equals 3x plus 3. AB equals negative 1 plus 2x. And BC equals 11. So again, I'm going to add the 2 smaller segments together, negative 1 plus 2x plus 11. And I'm going to set it equal to the whole segment, 3x plus 3. And I'll solve from there. So I have 2x plus 10. If I combine terms on the left-hand side, equals 3x plus 3. I want to get my x's on the same side of the equal sign. So I'm going to move the 2x. So I have 10 equals x plus 3. I'm going to move the 3 next. So x equals 7. And I was looking for x. So I can say x equals 7. Why don't you go ahead and try this first one on your own? Good luck. Hopefully you read the directions and ended up at HJ equals 17 units. If not, please be sure to reach out for some help and go ahead and solve this next one on your own. Good luck. Hopefully for the second one you ended up with x equals 13. If not, please be sure to ask a friend or myself for help. Alright, example 3, using the angle addition postulate. So we want to find the measure of angle KLM if the measure of angle KLB equals 26 and the measure of angle BLM equals 60. So KLB is 26 and BLM is 60. This is the same idea as the segment addition postulate, but this time we're using angles. So if I add those together to make the large angle, because I'm looking for KLM, so I'm going to add those 2 smaller ones together, and I get 86 degrees. Okay, and I'm going to be a little more specific. I'm going to say the measure of angle KLM equals 86, or I can say angle KLM equals 86 degrees. So this is a little different. I'm going to get nitpicky. I'm not going to be super harsh on this at the beginning, but I do want you to learn the difference. If there's an M here, there is no degree symbol with the 86. If there's no M in front of the angle symbol, if there's no M here, you have to use the degree symbol, okay? That is just some specific notation, okay? The second one here is the same idea, but with variables this time. So GFN, this is 4x plus 10. NFE is 14x plus 3. And the whole thing is 157. So I'm going to say 14x plus 3 plus 4x plus 10 equals 157. If I add those together, I get 18x plus 13 equals 157. 18x equals 144. So I can subtract 13 from both sides, divide by 18, and I get x equals 8. And I'm trying to find the measure of angle NFE. So NFE was the 14x. So instead of x, I'm going to plug in an 8 plus 3. So that's 112 plus 3, or 115 degrees. So I can say angle NFE equals 115, or I can say the measure of angle NFE equals 115. Go ahead and try this first one on your own. Good luck. Hopefully for this first one, you ended up at 84 degrees for the angle of WDC. If not, please be sure to reach out for some help. And go ahead and try this second one on your own. Good luck. Hopefully for this second one, you ended up at x equals 0. If you have any questions, please be sure to reach out for some help. And our last section. So we have already talked about congruent symbols and understanding that in class. So I'm just going to do a quick review. If a line segment has the same number of dashes on it, that means that they are congruent. Okay? So anything with 2 lines, it looks like is 11. So I'm going to label this 11 centimeters. Anything with 1 line is 8 centimeters. That's what my picture tells me. And I don't know what the 3 lines, what that measure is yet. Okay? So I'm just going to leave that. If I want to figure out what HF is, okay, HF is this line right here. So I'm going to add 11 to 8 in order to get 19 centimeters. I'm going to do that same idea over here, but with angles. Remember, anything with the same number of arcs in it mean that those angles are congruent. They are the same. So if that first one's 32, that second one is also 32. And I know that this whole angle is 127. So what I can say is I have 32 plus, I don't know what this center angle is, so I'm going to say x plus 32 equals 127. That should be a 2. And that is 64 plus x equals 127, or x equals, that would be 63. Okay, so that center angle is 63 degrees. So I'm going to say that the measure of angle YWV equals 63, or angle YWV equals 63 degrees. Remember, you don't have to write both of these ways. You can write it one way or the other. I'm just doing it to help you get used to both ways. Later on, I'll start just doing one way or the other. Go ahead and try this problem on your own. Good luck. Hopefully for the first one here, you ended up with 41.5 degrees. If not, please be sure to ask for some help. Go ahead and try this next one on your own. And remember, perimeter means that it's the distance around the outside, okay? So perimeter is the distance around the outside. Good luck. Hopefully for the second one, you added up all of the distances around the outside, set it equal to the perimeter. And when you did that, you should have ended up with AB equaling 11 and AB is congruent to GE, so we can assume that GE is also 11 units. If you have any questions at all about that problem or anything from this video, please be sure to reach out for some help, and I'd be more than happy to help. Have a great day.